Okay, in this lesson, we'll take a look at the unit circle. The basis of trigonometry will be a very special circle known as the unit circle. This is simply a circle that has its center located at the origin and has a radius equal to 1 unit, hence the name unit circle. Okay. From our work with equations of circles, which the following would represent the equation of the unit circle. So again, unit circle is a circle centered at the origin with a radius of 1. Okay. Well, how do we write the equation of a circle? Well, x minus a squared plus y minus b squared equals radius squared, where a comma b is the center of the circle. Well, hey, that's 0, 0 here. So we're going to get x minus 0 squared, or x squared, plus y minus 0 squared, or y squared, equals the radius 1 squared. And if we clean up the right-hand side, it looks like we get back choice 3. So the equation of the unit circle is x squared plus y squared equals 1. All right. Next, we will seek to produce some of the coordinate points that lie on the unit circle through the use of Pythagorean's theorem. The next two exercises will illustrate the important right triangles we will need. Okay, so in 2 and 3, in question 2, we're dealing with a 45, 45, 90 right triangle, an isosceles right triangle. And in number 3, we have a 30, 60, 90 right triangle. Okay. Consider the right triangle shown whose hypotenuse is equal to 1 and whose angles are both 45 degrees. Well, if they're congruent, that makes that isosceles, which means these two legs have the same length, which is why they're both labeled with an x. Solve for x and place your answer in simplest radical form. So this is a right triangle. We can use Pythagorean's theorem to solve. X squared plus x squared equals hypotenuse squared. Okay, so on the left we end up with 2x squareds. If we add those together, equals 1. Divide by 2. And now what we'll do is we'll take the square root. And don't forget your plus or minus. Well, actually, what I'll do here is we're solving for the length of the side of the triangle, so I guess we don't need the negatives here. So, look, x is going to be the square root of 1 over 2. Well, I can clean that up. That's the square root of 1 over the square root of 2. Square root of 1 is 1. I could write it like that. I don't usually like to keep the radicals in the denominator, so I'm going to rationalize this. I'm going to multiply this by the number 1 in the form of radical 2 over radical 2. Up top, 1 times radical 2 is radical 2. Down below, radical 2 times radical 2 is radical 4, or just 2. Okay, so we're going to say that's radical 2 over 2. So if we have a 45, 45, 90 right triangle with a hypotenuse of 1, we just showed that the length of the sides are radical 2 over 2. Okay, and on the next page, we're going to see how this ties into the trigonometry in unit circle. Okay. Now, consider a 30, 60, 90 right triangle whose hypotenuse is equal to 1. Clearly, this triangle is half of an equilateral triangle. All right, well, let's see. Is it? Let's see. If I were to double this triangle, here's another 60 degrees, here's another 30 degrees. Well, that makes that whole thing 60 degrees. And look at that. Yes, indeed, this is an equilateral triangle. So we have half of an equilateral triangle. Okay. So what does that mean? Well, the hypotenuse is 1. And this bottom now is going to be half of an equilateral triangle. If it was equilateral, that would be 1. But this is only half that, so what's that length going to be? 1/2. Okay. So what is the length of the shorter side? Well, we just showed that that is a half. Now we can use Pythagorean theorem to find the length of the longer side, or the height of this thing. Okay. So I'm going to call that x here, and let's set up Pythagorean's theorem. X squared plus 1/2 squared equals hypotenuse squared. X squared, squaring this, we get 1 over 4. Subtract a quarter. 1 minus a quarter is 3/4. So x is going to be the square root of 3 over 4, which is the square root of 3 over the square root of 4. Not much I can do with radical 3, but the denominator became 2. Okay, so in this case, if we have a 30, 60, 90 triangle, let me clean this up a little bit here now. Okay, the short side is a half. The hypotenuse is 1, and the longer side is radical 3 over 2. Okay? So let's see how this stuff now is going to tie into the unit circle. The diagram below represents the unit circle. Okay, it's centered at the origin. Okay, the overall circle is centered at the origin. All right. Notice numerous angle measures are labeled here. In quadrant 1 is where we're going to start. So notice we have 30, 45, and 60-degree angle measures labeled here, right? Those were the angles we were just talking about. All right, so let's now tie the triangles on the previous page to this stuff. Okay, fill in the ordered pairs. They actually want to know, what are these coordinates? What are these points? Okay, if I wanted to go from the origin, how far right and how far up do I have to go? What is that coordinate on the unit circle? Okay, that's what we're about to figure out here. Okay, let's start at 0 degrees, however. Now remember, this is called the unit circle because it has a radius of 1 unit. Okay, so that length is exactly 1 unit. Now, if I start at the origin and I take 1 step to the right, where does that take me? It takes me to the point 1, comma 0. So that's the equivalent coordinate on the unit circle to an angle that's at 0 degrees. Okay. Now let's look at 30. So what I'm going to do is I'm going to highlight this triangle. Here's my 30-degree angle. If I measure up 30 degrees, it takes me to this location on the unit circle. But what I'm going to do is I'm going to drop this down and I'm going to create a right triangle. And if that's 90, that means that that's 60. So what we have here is a version of the 30, 60, 90 triangle. And if you think about it, the hypotenuse here is the radius of the circle. So that's a length of 1, right? The hypotenuse of the triangle is also the radius of the circle. That's a length of 1. From the previous example, we showed the shorter side was a half and that the longer side was radical 3 over 2. Okay? So think about what that means for the coordinate. If I measure 30 degrees up on the unit circle, it takes me to this coordinate right here, where I would have gone right, radical 3 over 2 units, and I would have gone up half a unit. And so that takes me to the point, radical 3 over 2, comma 1/2. And now what I want to do is kind of emphasize, the importance of reference angles. Let's look at 150 degrees. Well, here what I'm going to do is I'm going to create another triangle where I drop back to the x-axis so that I have a right triangle. Okay, but think about this. That's 90 degrees. If this entire angle is 150 degrees, what's my reference angle right here going to be? How far is 150 from 180? 30 degrees. So look at this. I now have another 30, 60, 90 triangle. Okay? So it's all the same lengths that we saw on the right-hand side. The hypotenuse is still 1, that's the radius of the circle. The short side is still a length of a half. This longer leg on the bottom is going to have a length of radical 3 over 2. So in terms of the coordinates up here, x this time is going to the left radical 3 over 2 units. So we would have for the x negative radical 3 over 2. And for y, we're going up 1/2 a unit, so the y value is 1/2. Notice the values at 30 and 150 are basically the same. They're more or less the same coordinates. It just accounts for what's positive and negative in which quadrant you're in. Okay, let's look at 210 degrees. I'm going to make this triangle with a 210 angle degree rotation. Well, look at that. Again, 210 back to 180 would be a reference angle of 30 degrees. There's a right angle. Again, we have this 30, 60, 90 triangle. This would be a length of a half. This going left is still radical 3 over 2. So when we travel to 210 degrees on the unit circle, we go left radical 3 over 2 units, and this time down half a unit to take us to that coordinate. And what's the last angle that's going to be similar to this with a 30-degree reference angle? Over at 330 degrees. There's my reference angle of 30 degrees in quadrant 4. There's my right triangle. There's my 60-degree angle there. And again, that would be a length of 1/2. Hypotenuse is 1. Okay, so at 330 degrees, we are at the coordinate. We went right, radical 3 over 2, and down half. So again, look at these four coordinates, 30, 150, 210, and 330. They have very, very similar coordinates. They all have reference angles of 30 degrees. And again, their x and y values are more or less the same, positive and negative versions based on which quadrant you're in. Okay. All right, so let me clean this up. All right, and let's go ahead and look at 45 degrees next. So I'm going to highlight this terminal ray at 45 degrees. And again, same idea, we're going to make this right triangle. Here's my 45 degree initial angle there. That's 90, which makes that 45 degrees. Excuse me. Once again, the hypotenuse is the radius of the circle. That's a length of 1. We have the same 45, 45, 90 triangle we saw on the first page. The length of both legs, radical 2 over 2. Okay, so if I go to 45 degrees, I went to the right, radical 2 over 2 units. Oops. And I went up, radical 2 over 2 units. Okay, and now tying it to the other quadrants with reference angles of 45. Well, 45 degrees up from 180 takes us to 135 degrees. Okay, so same idea, except this time the x-coordinate's negative and the y is still positive, left and up. If I go 45 degree reference angle into quadrant 3, that takes me to 225 degrees. And I'll go ahead and draw the last one down here at 315 degrees as well. Okay, so there's those triangles. And so at 225, I went left, radical 2 over 2, and down, radical 2 over 2. So both those coordinates are negative. And at 315, I went right, radical 2 over 2, and down, radical 2 over 2. Okay, so again, this is why we study reference angles, because it allows us to work with larger angles in different quadrants and notice their similarities. Okay, let me clean this up, and then we'll take a look at the ones with reference angles of 60 degrees, which is back to our 30, 60, 90 triangle. If I measure up 60 degrees, and I drop down and make the triangle, well, now again, we're back to 30, 60, 90. Hypotenuse is 1. Short side is a half, taller side, radical 3 over 2 this time. So this time I went to the right, 1/2, and I went up, radical 3 over 2. Now, what do you notice about that coordinate versus the 30 degree angle? Right? They end up just being the flips of one another, because more or less we just flipped our triangle. Okay? And then it's going to be the same for all the other quadrants. Okay? 120 is going to end up being left a half and up, radical 3 over 2. 240 is going to be left a half, down radical 3 over 2, and 300 is going to be right 1/2, down radical 3 over 2. And now the only other coordinates we're missing are what are called the quadrantals. Those are the ones right on the axes, 0, 90, 180, 270, and 360. Well, again, 0 degrees takes us to the point 10 because we took a 1 step to the right. If I go 1 step up, I am at the point 0, 1. If I go 1 step to the left, I am at the point -1, 0. And where do we end up if we go down 1 step? Well, we end up at 0, -1. And if I go back to 360, I'm back to 1, 0. So this is going to be very handy, particularly for doing the homework, okay? Which is, figuring out the coordinates for all these angles. So you're going to want to find your reference angles, okay, which is what I've done, and then you can match them up to the values up on the unit circle here, okay. In any event, let's wrap up this exercise. For each of the following angles drawn in standard position, give the coordinate pair from the unit circle. So -120 degrees, okay. I mean, you can come up here and look at all this stuff for now, but basically here's how I do these. So I know -120 is going to put me over here. This is -180 degrees. And so I have a reference angle of 60 degrees. Okay. So I just want to be at whatever coordinate corresponds to 60 degrees in the third quadrant. Well, that's what our 240 right there, and there's the coordinate -1/2, negative radical 3 over 2. Okay. Part B, 495 degrees. First thing we got to do is subtract 360 from that, and that's the same as 135 degrees. Okay, so I'd have gone all the way around, plus another 135, taking me up into quadrant 2. This is going to have a reference angle of 45 degrees. So I know it's going to be radical 2 over 2 and radical 2 over 2. I went left, so negative radical 2 over 2 for x. I went up, positive radical 2 over 2 for y. Okay, now working in terms of radians, again, for now, I would recommend converting into degrees. It's probably just going to be easier for you. So pi over 3, I'm going to multiply by 180 over pi. That becomes 180 degrees over 3 is 60 degrees. Okay, so I can come up here, again, look, it's 60 degrees. I'm at 1/2 radical 3 over 2. And for part D, 180 over pi. Okay, 3 times 180 divided by 2 ends up being 270 degrees. That's a quadrantal. We can see it right down there at the bottom of the screen. 0, -1 is the coordinate. Okay, so use this to help you with your homework. Okay, you're going to see a lot of the same coordinates showing up. Just take your time, go through these, pause as you need to get help with the solutions. Okay. Number 3, a little more algebraic. We're just using this equation, sub in for x and y. Make sure you get 1 back. Here again, we're using this equation. They gave us either x or y, and we're solving for the other value. Here, when you take the square root, watch for your pluses and minuses, okay? Shoot me some emails if you have questions. Have a great day.